All right, in this one, let's start looking at graphing exponential functions. The graphs of all exponential functions have similar characteristics. Before we do that, let's review the properties of exponents. Now, if you need to stop the video right here and look at those and get them back in your head, it may be a while since you've studied them. Do so because we're going to make a lot of use of those in the next couple sections. Now, let's notice what happens of various things. We're going to animate some plots. Here we're going to start with a to the x, where a is between 0.1 and 1. A has to be greater than 0, but it can take on a lot of different values. So please watch how this grows as a moves from 0.1 to 1. Notice when we get to 1, we have a horizontal line. Okay, so when a to the x for 0 less than a less than or equal to 1, a varies from 0.1 to 1 at x equal to 1. As I said, we have a horizontal line. Now, let's switch a little bit. Notice in this case, we're going to let a go from 1 to 4. And we're going to animate it through 31 frames, but it's going to only draw 4 of them. So watch what happens as this goes. A goes from 1 to 4, like 1 to x, 2 to the x, 3 to the x, 4 to the x. Notice how we have an increasing function here. At x equal to 1, we still have our good old horizontal line, because 1 raised to any power is still 1. That's neat. Now, in this case, let's raise a to negative exponents. Okay, we're going to go back to the a equal to 0.1 to 1 and watch what happens when a is 0.1 to 1. You're going to find that it resembles when we had a to the minus x there. A varies from 0 to 1. At x equal to 1, we have a horizontal. Kind of think about which one that looked like. Now let's go to a to the minus x again, but let's let x between 1 and 4. Remember, this would be the same as having 1 over a to the x. So between 1 and 4, check out, this is going to resemble one of the graphs we've already looked at, except it animates it in a different direction here. So a varies from 1 to 4. We still have a horizontal line at x equal to 1. So let's look now at some of the properties of exponential functions. The graph of f of x equal to a to the x if a is greater than 1, for example, 1.5, 2, and 3. Notice the domain is minus infinity to infinity. The range is 0 to infinity. We have one y-intercept. It's increasing. X-axis is a horizontal asymptote. If we have a to the minus x, but a is still greater than 1, 1.5, 2, and 3, notice what happens. The domain is minus infinity to infinity. The range is 0. That didn't change. The intercept didn't change, but we now have a decreasing function on minus infinity to infinity. A to the x minus x approaches 0 as x. Now, remember, we studied all those transformations in Chapter 1. They can be applied to exponential functions also. So, for example, notice how 2 to the x and 2 to the minus x are reflections over the y-axis, whereas 2 to the x and minus 2 to the x reflect over the x-axis. We can have vertical translations. Notice that we have 2 to the x in red. If the blue is up 2, the green down 2 from. Notice the y-intercept. That's how you can tell the difference. Now this next one deals with horizontal translations, and they're a little bit harder to read. So I had to put an extra line in to help you there. 2 to the x, 2 to the x minus 2, 2 to the x plus 2, and notice how the point where y is equal to 1 moves to the left and right when I have horizontal translations. So the line y equals 1 is to help you see where they intersect.